Okay, the problem I'm going to describe the problem which I will solve here. So the problem is from DBMS, Database Management System. In Database Management System, what happens? So what is database? The first I'm going to the problem, then from that problem I'm going the related topics, then so that it can be understood how I come to the answer. Okay. Now in database there is a table which is called relation. The database what on which we manipulate data, and data are kept in some relation which is in our language we can call it a table. It will have some rows and some columns. So there is a so that is called relation. So relation means it is a table, so it has some it has a, just like table, it has some rows, some columns. So relation is like that, a table which have some rows here are called tuples. Rows are called tuples here, and the columns are called attributes. Attributes. So relation is nothing but a table. Now in table there will be some rows which are called here tuples, and there are some columns in a table which is called attributes. In case of relation it is called attributes, but the concept is similar. The concept of tuple is same as row, and concept of attributes is same as column, and the table relation actually indicates a table. So in a table there are data which have relation with each other, so that is called relational data. So whatever the data we are putting, we're keeping it into a relation that are related with each other, so that is called relational data. So now how to manipulate this data? The data can be manipulated. So how to manipulate the relational data? So for that there is some operators which are there is relational algebra, so that we can manipulate relational data. So the term is called relational algebra. So what is that relational algebra? It constitutes of some operators which is relational algebraic operators. Relational algebraic operators which are used to manipulate the relational data which is maintained in a relational database. So relational algebraic operations. So and when now in this relational algebra, as an input we take a relation. As an input we take a relation, then the particular operation is being performed on this relation, and the output is also in the form of a relation. Okay, so it takes as input a relation, then after doing some operations on that relation, so that the data that is within that relation that is manipulated. Then after manipulation the required result is being outputted as in the form of a relation. Now, when we take input as relation, it is not that only we will do only a single operation. No, it is not that. In that relation, suppose I take an input as a relation, then we do some relational algebraic operations on it, and after doing the operations, the output is a relation, and on that output also I am doing some other operations, then that also gives output a relation. So that means we can do a sequence of sequence of relational algebraic operations. So when there is a sequence of relational algebraic operation that is expressed, then that is called relational algebraic expression. Relational algebraic expression. So that is relational algebraic expression is denotes a sequence of relational algebraic operations that are performed onto some relation, and after performing the operation it gives output in the form of a relation. So here in this particular example, so we will use a relational algebraic operations, and after, so that it will do some manipulation of the data which is stored in that relation. Then after that, so the question is that what does this relational algebraic expression generate? So when we perform some operation on a relation, so here a particular relation has been given and the expression also is given. So after doing that relational algebraic operations, the sequence of relational algebraic operation, and how the sequence of operations are expressed in the form of relational algebraic expression, then we obtain the output. So the question is, a relation is given and also the relational algebraic expression is given, then what that expression will generate? That is the question. So here, before that, before telling the relational algebraic expression, I have to tell the what is the relation. And suppose in a particular relation, suppose there is a number of employees in a company. Now there can be a relation like employee. In that relation there will be columns or attributes like employee number, employee name, employee address, employee phone number, etc. So in that attributes, there will be a combination of more than one attribute, so that uniquely identifies a row in that relation, that uniquely identifies a tuple uniquely in that relation. So that combination of attributes, one or more than one attributes can uniquely identify a particular row in a relation. So that is called, that attribute or a combination of those attributes is called a key. That means which are used to identify a tuple uniquely from that relation, that is called key. So key can be a single attribute or a combination of more than one attribute. So here the relation records the age of 500 employees of a company. So a company, there are 500 employees and there is a relation. So the relation name is given as employee age. That is the name of the relation. And what are the attributes in this relation? In this relation, that relation is required to record the age of the 500 employees of a company. So what are the attributes are there in this relation employee age? And attributes is employee number, which is the key for that particular relation, and age is another attribute for that relation. So by employee number, we can uniquely identify a particular tuple from that relation employee age. Now the relational algebra is given like that. There is a so relational algebraic expression is given. So I told you the relational algebraic expression is the combination or a sequence of operations. Sequence means one operation, then after that next operation, then after that next other operation will be done. So sequence of operations will be performed. So when the sequence of operation, how it can be expressed? By using relational algebraic operation. So here the relational algebraic expression is given here. So pi is a symbol which is known as projection. So what are the relational operators, because that are used in this expression? So we have to know what are the operators are actually. that is relational algebraic operators. We will come to that. Before that, I want to write the expression, relational algebraic expression here. So the expression is pi. Pi means the name of this operator is known as projection. Projection means, suppose there is a relation and there are suppose 6 or 7 attributes or columns. Now from that relation we want to extract the information or of all rows on that relation, but that will only consisting of two or three attributes. So we from the state of attributes we are finding a subset of that attributes for that particular relation. Then that operation is called projection. So here is a projection operator is written in this way, pi, and what are the information we want to extract. So what are the attributes that we what are the attributes that we want to extract from that relation? And the attribute is employee number. Okay. So that is the last operation, but I will first tell you what are the operation that has been that are done first. Okay. So another operator which has been used, that is this is called the join operation. It is called a join operation. What is the join operation? Suppose when there are 2 or more tables we want to join other based on some condition, then that is called conditional join. So here this operator is a join operation, and as the condition is given as age is greater than age 1. Age is greater than age 1. That means two relations here are being joined with a condition satisfying that age, it will be greater than age 1. And what is that age 1? I am coming to that. But here so what are the operations? So that is natural join operations that is to be done, and for conditional join, and this conditional join we need two relations, two or more than two relations, that I will discuss. Okay, then another operation is known as row, means rename operator. Rename means suppose we want to there is a relation we want to rename it, then we can use this operator rename, or else we can rename its column, its attributes also we can give a different name. So suppose now row is a rename operator that we are here the rename operator used to rename the attributes of an employee age table. So in employee age table only two attributes are there, employee number, employee age. But we are using employee age table, so that it's these two attributes, the name of this attribute has been changed. So employee number has been changed to employee number 1, and age, this attribute name has been changed to age 1. This attribute name has been changed to S1. And on which relation this attribute belongs? Now this attribute belongs to the relation employee age. So that is the rename operator we are applying on this relation table, and we are renaming its two columns, which are employee number is being renamed as employee number 1, age has been renamed as age 1. So we are using this rename operator to rename its all attributes of the table employee age. Now this is being that is one operation. First we will do the rename operation of that employee age table. Then number 2 operation is we will do the conditional join. Conditional join between which? The conditional join between employee age table. Employee age is only a single table, but we are taking another copy of that employee age table, and in that copy I am renaming its attributes as employee number 1 and age 1. Then we will do the joining of that same relation, but we are joining them. So here the second operation will be this conditional join. Here the two employee age table we will take, one will be left hand side and another will be right hand side, this one. So in left hand side there is the age column, and in right hand side there is the name of the attribute. Age is becoming age 1. So condition is that age should be greater than age 1. Based on this condition, we are joining the employee age table, taking its duplicate copy. So we are doing a conditional joining. After doing joining operation, we get a relation. So in that relation, we are only projecting only the employee number, attribute employee number. From that, we are doing the projection operations. So what are the sequence of operation? Here are the 3 operations we are doing in this sequence, 1, 2, 3. So how the relational expression or relational algebra is being, is written here. First of all, we are doing a conditional join, and here first we use the rename operator. So we are doing the rename operator by renaming the employee number column to employee number 1 and age table as age column as age 1, and these columns are being taken from the relation employee age, and this is one copy of employee age and the original copy of employee age table. Between this same table, taking two copies, we are doing the conditional join, and the join is based on which condition? Now the age, that means the age from this employee age table should be greater than the age 1. That means age 1 from this duplicate copy of the employee age table. Then after doing this conditional join, what we are doing? What we are getting a relation. In that relation, what the attributes will be there? From this table employee age, there will be tables employee number and age, and that will be joined with this another duplicate copy of employee age table, in which the employee number is given name employee number 1 and the attribute age is given name age 1. So 4 attributes will come in this output relation. After this operation, what will be the output relation? Here we are getting the 4 attributes in that, and from that 4 attributes we are extracting only the employee number attribute. So that is called, we have to use a projection operator. And which attributes I am projecting here? The employee number, that means which belongs to this employee age table employee number, because in the duplicate copy of employee age there is employee number 1 column name. So we are extracting only the employee number attribute or employee number field from this corresponding relation. Then that employee number is giving the output, where only employee numbers will be there in that output. That is also a relation containing only one attribute, which is employee number. So that is the meaning of this relational algebraic expression. Now while explaining the relational algebraic expression, this is clear that how rename operator is used. For example, the employee number table has 2 columns, employee number and age. So suppose, for example, we are taking some data into it, taking some tuples. We are creating some tuples for clarification purpose. I am using an instance of that table employee age. So what is that? Suppose employee age table which has only 2 attributes, employee number and age. Employee number and age. Suppose the employee numbers are 1, 2, 3, 4, then 5, and suppose age is 10, 15, then 20, then 40, then 30. These are the age. Suppose there are 5 employees and the age are given. Now what we are doing, when we will using the rename operator, that row, this symbol is row, employee number attribute is renamed as employee number 1, age attribute is renamed as age 1, and from which relation I am taking this attributes in employee age table. So So this two instance. Now there is another instance of employee age table, and here the column name or attribute name is employee number 1 and the age name is age 1. So the duplicate copy, the data within this table, that is not getting changed here. Only the attribute name has been changed. Because why this attribute name I have changed or I have renamed it, that I will explain. Now this employee number 1, 2, 3, 4, 5, then age 10, 15, 20, 40 and 30. Now what we are doing, we are taking the two employee age table, the two copies of that. So here it is employee age. Now I am doing the conditional join based on which condition the age should be greater than age 1. This is the condition. Now conditional join, we have to understand it very properly, that what is conditional join. Conditional join, suppose conditional join, there is some operator which can be which is known as derived operator, because in relational algebraic operator there are some basic operators, and from that basic operators we are deriving some operators, then it is called extended operator or derived operator, and conditional join is that kind of operator. So if conditional join is kind of extended operator so that it can be derived from the basic operator, then what is those basic operators that conditional join can be expressed in terms of basic operators? The conditional join is that, this is the conditional join. This conditional join means first you do the, suppose there are two relation R1 and R2. So R1, R2, you do the, this is called Cartesian product. This cross is a basic operator in a relational algebra. So that is called Cartesian product. Cartesian product means each tuple of or each row of the R1 will be multiplied by each row of R2. So if there are suppose 4 rows in R1 and 5 rows in R2, then in after Cartesian product operation, so each of the row in R1 will be multiplied with each row of the R2. So in R1 cross R2, how many number of tuples will be there? Now 4 into 5 equals to 20 tuples will be there. For example, if we do the Cartesian product between these two copies of employee age table, in employee age table there are 5 rows. So 5 into 5, 25. After doing the Cartesian product, we will get the 5 rows or 5 tuples in that in that output relation. So what are that 5 rows? Here is a space problem also, but still I am trying to write the all 5 rows which I obtained. So what is the operation I am doing? Employee age. We are doing the Cartesian product. We are doing the Cartesian product where the row is named as employee number 1 and the age is renamed as age 1, and we are doing the Cartesian product of employee age table. So after this operation, what is the output relation we get? Now I told you that in each of the in table there are 5 rows. So in this, after this operation, there will be 5 into 5, 25 rows. So what will be that rows that I am writing here? This is employee number and this is one row, one column, and this is age. Now this 2 column or 2 attribute is coming from this employee age, and employee number and age 1, these 2 attributes are coming from this employee and copy of employee age. So that is employee number 1 and the another tuple is age 1. So how many records or how many rows will be there in this output relation? So first, what is the value? 1, 10. Employee number is 1, age is 10. Now this will be multiplied with every rows from the second employee age table. So then what will be done? 110 when multiplied with this first row, we get employee number 1 and age will be 10. Next again 110 will be multiplied with the second row of this employee age table. So employee number 1 is 2 here and age is 15 here. Similarly, employee number 110, that means first row, will be multiplied with third row of the second employee age table. So employee number 110 and employee number 1 will be then 3 and age 1 is 20. Similarly, employee number 110, there will be employee number 1 4, age 1 will be 40. Then employee number 110, there will be employee number 1 will be 5 and age 1 will be 30. So first row in this employee age table is multiplied with age each of the rows of the second employee age table. Similarly, that will be done for second row of this employee age table. So second row means 2 employee number, age is 15. So 2 employee number is 2, age is 15, is multiplied with this employee number 1, age is 10. So 1 10. Similarly, 2 15 will be multiplied with second row of this employee age table. That means employee number 1 will be 2, age 1 will be 15. So that is 2 15. Similarly, 2 15 will be multiplied with employee number 1 equals to 3 and age 1 will be 20. So it will be 3 then 20. Then employee number 215 will be multiplied with row employee number 1 will be 4 and age 1 will be 40. So 440. Then 215 will be multiplied with the last row of this employee age table where employee number 1 is 5 and age 1 is 30. So 530. Then second row, for the second row, each of the row in this employee age table has been multiplied. Then we will take the third row from this employee age table. In third row there is employee number 3, age is 20. So 320 will be multiplied with every row in this employee age table. So it will be 320 110, then 320 215, then 320 320 320 440, then 320 530. Then we will take the fourth row in this table, which employee number is 4 and employee number and age is 40. So that will be multiplied with every row, from this employee age table. So what will be the record row in this table? Now 440 is multiplied with 110. Again 440 is multiplied with 215. Then 440 is multiplied with 320 and 440 is multiplied with 440. Then 440 is multiplied with 530. Then if we come to this table, the last row is 530. Employee number is 5, age is 30. That will be multiplied with every row in this employee age table. So what we will do, last row of the employee age table will be multiplied every row in the employee age table. So how it will become? So 530 here, 530 is multiplied with 110. Then 530 is multiplied with 215. then 530 is multiplied with 320, then 530 is multiplied with 440, then 530 is multiplied with 530. Now when this has come, see, if you see the total table, this table where the attributes are employee number, first attribute age, second attribute employee number 1 is a third attribute, and age 1 is a fourth attribute, and these are the rows in this table. Now that has been done by the Cartesian product between employee age and another copy of employee age. We are doing the Cartesian product. Now we want to do the conditional join. So after this Cartesian product, we apply next operation, selection. Selection operator is written in this way. That means we will select the rows from that output of the Cartesian product operation, so that it will select some of the rows from the table. There are 25 rows in this table, but we will select some of the rows from the table based on some condition. The selection of some of the rows will be done. So when this Cartesian product, after Cartesian product, will select some of the rows from that relation, then we will get a conditional join. So here the condition is what? The age should be greater than age 1. So we come to this relation. When there is a age, second attribute, and age 1 is fourth column, and we will select only those rows for which the age will be greater than age 1. So if we see the first row, 10 is age 1 is 10. So this row should not be selected. Next, second row, 10, age is 10, age 1 is 50. So age is not greater than age 1. Now here age is 10 and age 1 is 20. So age not greater than age 1. So we will not select this row. The next row, age 10 and age 1 40. Still age is not greater than age 1. So we will not select this row. Next, age is 10 and age 1 is 30. That age is not greater than age 1. So we will not select that row. Now next, come to next row. Age is 15 and age 1 is 13. So here for this particular row, the age is greater than age 1. So we will select this row. So here we are in this. So what will be the rows that we are extracting from this relation? So I'm writing that employee number and age, then employee number 1, then age 1, then age 1. So what are the rows that will be selected from this table? That will come here. So here 2, 15, 1, 10. So employee number 2, age is 15, employee number 1, age 1 is 10. So this is one row from this that comes as the that comes in the output relation of the conditional join. Next, here we come that age is 15 and age 1 is 15. So that does not satisfy the condition. The condition is age should be greater than age 1. Next, 15 age and age 1 is 20. So age not greater than age 1. Next, 15 age 1 is 40. Age is not greater than age 1. So we will not select this row. Then age is 15, age 1 is 30. So age is not greater than age 1. So we will not select this row. Next row is age is 20 and age 1 is 10. So here age is greater than age 1. So we will select this row. So this row becomes, it will come here, employee number 3 who has age 20 and the employee number is 1 and age 1 is 10. Now next, age is 20, employee number and age 1 is 15. So age is greater than age 1. So this row will be selected. So here that will come employee number 20, employee number 3, age is 20, and employee number 1, 2 and age is 15. Now here age is 20 and age 1 is 20, so that does not satisfy the condition, so we will not select this row. Then age 20, age 1 40, so age is not greater than age 1. Again age 20, age 1 30, age is not greater than age 1. Next age is 40, age 1 is 10, so age is greater than age 1, so we will select this row. So what is the row? 4 is the employee number whose age is 40 and age 1 is 1 whose age is 10. Next 40 is age and 15 is age 1. So here also age is greater than age 1. So we will select this row. So what will be there? Employee number 4, age is 40, then employee number 2, age is 15. Next employee number 40, employee number 4, age is 40 and age 1 is 20. So we will select this row. So here 4, employee number 40 age and employee number 1 3 and age is 20. So we will select, we have selected this row. Next is age is 40, age 1 40, we will now select this. Then age is 40 and age 1 is 30, so we will not select this. Then comes employee number 30, age is employee number 5, age is 30 and age 1 is 10. So age is greater than age 1, so we will select this row. So employee number 5, age is 30, employee number 1, age is 10. Then employee number 5, age 30 and age 1 15. So age is greater than age 1. So employee number 5, age is 30 and employee number 1 becomes 2 and age 1 is 15. So next employee, next row, employee age is 30 and age 1 is 20. So this row is extracted. So employee number 5, age is 30, employee number is 3 and age 1 is 20. Next employee number 5, age is 30, next row, and age 1 is 40. So it will not be selected, and age is 30, age 1 is 30, so it will not be selected. So this becomes the result of the conditional join between these two instances of employee age. These become the condition. Now here, on this relation, if we the output of this conditional join, if we see it, notice the result, then we can observe one thing, that is what we can observe. We can observe here only the employee, those employees we are find here. What are the employees? Age of the employees here, what? Now 15, 20, then 40, 30. So these are the employees, and these employees' age is greater than all of the employees in this fourth column, third and fourth, all of the employees in this third column. That the employees in first column, employee number is whose age is greater than all employees which are in employee number 1, and whose their age is on age 1. So all of these employees in this first column has more ages than employee number 1 of this particular on this third column. So what we are getting? We are getting all the employees whose age is not the minimum. We are getting all the employees here whose age not the minimum. See, 15, 20, 40, 30. 15 should be greater than lowest age. Here if we see, the lowest age is 30. Lowest age is 30 and the highest. So there will be all employees here after conditional join whose age is greater than at least 30. Whose age is greater than the lowest value, because here age should be greater than age 1. So if age is 10, then it cannot be greater than any employee. But if age is 15 or 20 or 30 or 40, those employees all are greater than those employees whose age is 10. So here we are getting a relation, getting the answer. These are the employee numbers whose age is not the minimum. Whose age is not the minimum. So on this table, if we just do the projection operation pi and the pry will only project only only one column, employee number table, employee number. So in employee number, this rows will be extracted. Now 2 will be extracted, 2 will come here, 2 will come here, then 3. If there is any duplicate row, then that will be merged. So that will be only once in that output table. We are doing the projection from this employee number attribute. So 3 will be there, then 4 and 5. So we are getting the employee numbers of those employees whose age is not the minimum. So that was the resultant expression that was provided here, that after doing the conditional join, we are doing the projection on the attribute employee number, so that we are getting the employee numbers of all those employees whose age is not minimum. Now that is the thing that we are finding it here by this conditional join, then after the projection. So now this was given. Now the question is, I'm telling you the question, that I'm question writing here. Here, just by giving an example, I want to see if I do the conditional join on the same table, and based on the condition that the age age should be greater than age 1. So if it is not the minimum age, then obviously it should be greater than the age 1. That means every age which is not the minimum, that will have some employee which from which they have the higher, greater age. So who is not just the minimum, that also age will be displayed here, because that will be greater than the lowest minimum aged employee. So we will get the employee numbers of all those employees whose age is not the minimum. So here the question is, what does the above expression generate? First one, it is telling that employee number of only those employees whose age is the maximum. So it is not true. Second option has been given, employee number of only those employees whose age is more than the age of exactly one other employee. That is also not true. Third option is employee number of all employees whose age is not minimum. So that is the correct answer. And the fourth option was employee number of all employees whose age is the minimum. So among this fourth option, the third option is right, that we are getting the employee numbers of those employees which age is not minimum. So by this relational algebra expression that we are doing, first we are doing the conditional join between employee age, then conditional join based on condition age should be greater than age 1. And what is that age 1? There is a rename operator row where the attributes of the employee age table will be renamed, because we are taking a duplicate, a copy of that employee age table, so that attributes needs to be renamed. Otherwise, how we can differentiate that this attribute is for first employee age table and this attribute is for second employee age table, because they are the same table. So that needs to renaming of another copy, that needs to be renamed here. So here the renaming of attributes is employee number 1 and age is renamed as age 1, and these tuples we are getting from the table employee age. So after doing conditional join, we are just projecting the employee number. So we will get, so what is that expression generate? This expression generate the employee numbers of all those employees whose age is not minimum, So this expression generates this answer. So how to find out this expression tells how to find out the employee numbers of all those employees whose age is not minimum. Now there were four options, and among this option was there, and which is the correct answer. But what are the other operations? If we are find out the only find out those employees whose age is the minimum, is that option can be, is that answer can be generated by some other relational algebraic expression? If that, then what will be that relational algebraic expression? That means we want to find out the how the relational algebraic expressions will be there. If we want to find out the employee numbers whose age is minimum, So how to find out this, how to find out this answer to this query by writing a relational algebraic expression. Now in this expression we have find out all those employees whose age is not minimum. That means in table, employee age table, there are now employee age table will contain the employee age table. Employee age table contains employees whose age is not minimum. Employee age table contains those employee number whose age is not minimum plus whose age is minimum, plus those employees contains employee number those employees whose age is minimum. So what we will do, from this employee age table we will do a difference, do a minus, which is called set difference operator. Suppose there is a set, suppose A, B, C, and suppose this is set A and there is another set B which contains only B and C. That means this is a proper subset, B is a proper subset of B. Then if we do the set difference operator, that is A minus B, then we will get BC is both here, but A minus B means which is in A but not in B. So only this small a is there which is in set A but not in set B. So answer will be small a. So it is like that employee age table contains a set of those employee numbers whose age is minimum plus whose age is not minimum. So from there, if we do the minus of the set of which is found out from this expression, that whose age is not minimum, then obviously we will, if we do the set difference operator, then we will get the age numbers of those employees whose age is the minimum. That means employee age table, employee age, so that result operation employee age minus suppose this relational algebra expression I am giving the name as employee age not mean. Employee age not mean equals to this. So employee age is contains those employees which the employee number of those employees whose age is minimum plus whose age is not minimum. So from this table, if we do the minus of employee age not minimum, then we will get the answer, that is employee numbers of those employee whose age is minimum. So employee age minimum equals to employee age minus set difference order employee age not minimum. Employee age not minimum is this one, the employees of those whose age is not minimum. Now total employee age table contains those employees who has the minimum age and who has not the minimum age. So from that total, if we difference those whose age is not minimum, then obviously we will find the set of those employees whose age is minimum. So that is the expression. So here I am giving this expression name employee age not minimum, and after doing a set difference order from the total original employee age table to employee minus employee age not minimum, then we get employee age minimum. So if we do the relational algebraic operator, if we give a name for simplicity, but we can write here in this way, employee age minus, here also one thing, here if we do the set difference operator, then obviously the here obviously they have the same set of attributes. Here in employee age not minimum, there was only the attribute employee number, and here employee age table there are I mean there are two attributes, employee number and age. So here I have to do a projection operator, and here I will find the employee number. So projection of employee number from the table employee age minus set difference employee age not minimum. So if we replace it by this relational algebraic expression, so what is the resultant expression looks like? It will get the employees numbers of those employees whose age is the minimum. So projection of which attribute employee number, and from which relation employee age, and from there we are doing the set difference operator and the projection employee number. When we are doing this is set relational algebra operator, just set difference is relational algebraic operation, but is set oriented operation. In that case, both of the employees on which this operation will be performed, they should have the same attributes. So that's why I have here I'm getting employee number, and here also that I need a projection to get, so that they will have the same attribute employee number. So here employee number and the employee age was done a natural conditional join where age was greater than age 1, and here the rename operator was used, which was employee number 1 then age 1, and the table was employee age. So when we do this, then we will get this relational algebra will give you the employees whose age is the minimum. Now the third query was what? So after this I am doing here. Next we will come to more detail. Okay.